So shall I start? Yeah, awesome. Right, hi. My name's Rob Sims. I'm currently a PhD student at Lancaster University. I'm actually due to finish in a month, so I'm in my writing out phase at the moment. My specialisation is in topic agnostic tools that we can use in VR for education. So rather than something specific like how to program, I'm interested in things like mind maps. So yeah, stuff that we can teach any topic in. So we currently teach a master's module at Lancaster called HCI Advanced, and as part of that, I teamed up with a cohort of master's students on their project, which is what this presentation is about. So that's why we've got quite a long authors list. So after myself, so you've got Barry, Verity, up until Zoe. They're all the master's students, and then they were supervised by Dr. Christopher Clark from Bath University and Dr. Abe Karnick, who's Lancaster University, who's actually my supervisor as well. So the challenge that they had on their HCI project, so they had 10 weeks to do this, and they had to implement a system that would benefit a homogeneous group. They selected higher education students as their target group, and they also chose the principles of pedagogy, which is, if you've not heard of that, that's peer-based learning. And they also wanted to look at collaborative learning as the focus for their system, which is why we're in this special track. And that actually lines up quite nicely with my PhD specialisation, I think, as well. So the learning that they wanted to focus on was mind palaces. So the concept of a mind palace is a technique for memory recall. It's quite well researched. There's quite a lot of pedagogy around it, and it's well proven to improve. It's like a spatial mnemonic technique where information is associated with various aspects of an imagined environment. So that environment can be hosted by immersive technologies such as VR, or you can do it through desktop as a 3D environment. So there's been a lot of research in mind palaces in VR, and it's been shown to enhance productivity through superior memory recall. There's also there's quite a lot of comparison studies as well in our literature that we found. So mind palaces in VR show that performance is increased versus traditional desktop alternatives. So it was a nice thing for them to focus on. But because that's quite well researched, they wanted to bring something else in that would complement mind palaces as well. So for this, they look at space repetition. So space repetition is a repetitive technique to train the brain to retain knowledge for long-term memory. So using space repetition in active learning strategies, it strengthens the review and reflect elements of active learning. It's a heuristic technique which also increases efficacy of learning compared to mass learning, and it also boosts learner confidence. One of the main areas of focus in space repetition is how do we identify the timing protocols and build algorithms to create the optimal times for when repetition is carried out. So that space repetition combined with mind palaces was their kind of, let's see if we can do that in VR, and they found a gap in the literature that no one's really kind of done that. So we got onto our system. So they built a system, bearing in mind this was in 10 weeks as well, and they probably only really built it for about 7 weeks because they had a lot of introductory material. So they built a system which they call Clever. So the main objective of Clever is to present certain types of learning resources in a collaborative environment. So that feeds into the pedagogy, and it utilizes the mind palace and space repetition techniques. The learning objects or resources that that goes into this system are derived from existing material. So it could be text-based resources, image-based, audio, video resources, or interactive 3D models. But this is all populated by the actual learner themselves. So, self-directed learning. On the video that we've uploaded to the iLRN space, there is quite a nice walkthrough that Verity did. It's about 2 minutes. It gives you a walkthrough of the system. So I can't really give you much of a description on here, but there's a bit of a screenshot there. But yeah, if you want to know more about the actual system and how it's set up, the video is a really cool place to go. So I'm going to concentrate on the study, the results, and the discussion that arises from that. So for our study, we conducted an expert user review and and an online study, which was adapted from a standard user experience survey. It's called a UES. The reference is in the paper. So we used that to obtain feedback on user experience and the perception of using Clever. So this study as a whole was more of a user perception and a viability study rather than a usability study, because that would come next once we, why do a usability study on a tool if no one wants to use it? So that's why we kind of phrase this as a perception. So the way we ran the study, participants were accompanied virtually by an experimenter within Clever. Bearing in mind this was all in the COVID lockdown restrictions as well, so this was quite hard for us to actually do the study, but we got around it. So this allowed us to replicate the experience of collaboration with this experimenter, and we tried to reduce experimenter bias by following the same preset kind of structure interactions through each iteration with each participant. Participants were asked to complete Clever's tutorial to familiarize themselves with the system, and then participants were asked to interact in the Clever world and see what they could do. Finally, each participant was asked reflective questions about the system. If at any point the participant did use a headset or binocular VR for exploring Clever, they also had to fill in a motion sickness questionnaire just to make sure we hadn't introduced any kind of bad behaviors or symptoms in there. Each participant took a minimum of 25 minutes, but we had it as open-ended. If they wanted to spend an hour in the system, they could, so that was fine. So on to results. So for this was the expert review. So participants were asked to provide feedback on the experience. In the overall sense was the program came across as user-friendly. 6 out of 7 participants responded that they would be interested in the final project. So that goes back to, we're kind of trying to just get whether this is a viable tool or not. Some of the ideas of how they would use Clever were they liked the way it was customizable and they could put their own interactive revision materials in. They liked having all their revision materials in one place. And most participants stated that they would like to use Clever as a future revision tool. We also asked the participants to rank system features, which you can see the table on there. One of the surprising ones, I think, was the actual memory palace wasn't that strong, but the spaced repetition, they liked the way that that took them through. And they also, when we were looking at our user comments as well, they liked the spaced repetition doing that with their peers. They felt that doing the same revision at a certain time through spaced repetition with their peers created a stronger story as opposed to just doing the spaced repetition on their own. So so that's why you've got hosting other users and visiting other users' environments was one of the higher scores there as well. And then obviously immersion came up quite high. But yeah, I think the spaced repetition was the thing that came strongest over that. So that was the expert review, and then we actually looked at the proof of concept as well. So this was so due to lockdown restrictions during the study phase, this part of the second study was planned as an online-only survey. So they were played an interactive video demo of Clever, and then they were asked to comment on the aspects that they saw through that video, which is also one of the videos that's linked in the iLRN one that we uploaded. So although all participants responded that they engage in collaboration for study and revision, hosting others in the environment this time was only the 5th most important feature that they thought they would use. So while the expert review said that was strong, when we actually asked people to comment on the demonstration, they weren't sure. So there's a bit of a disconnect there between their experience of using the system and their perception of how a system would be used. So yeah, that was odd. And we asked them, does this product sound like something you would be interested in using? So 69% responded yes, and 19% were undecided, and only 12% chose probably not. So coupled with a lot of the other stuff that's in the paper that we haven't really got time to go through, the perception of this system demonstrates that it would be a system that people would like to see developed and they would like to use for their own learning. So that kind of feeds into the discussion. So for the user's opinion about the system, the open-ended responses were mainly comments, were mainly positive comments. They were focused on being engaging, useful and fun, and users could visualize the potential in having all their revision materials in the same place. So thinking about through a pedagogical lens, one of the things that a lot of the comments came through, and it's interesting because we actually had a couple of education students on. They kept referring through to VARC, so you know the old traditional visual, audio, reading and kinesthetic. So the old style was that everyone thought they had their own method of learning, and you had to teach to that method to hit them. Now the modern theory is that everyone at some point during their learning experience during the day or even through a session needs each of those. So it's what we call multimodal teaching now, and a lot of the people thought this would be a perfect multimodal learning tool. So you've got your visual, audio, because you're in VR as well, you've got your kinesthetics, you can move objects around, and that ties into the memory palace where you can place objects in different places. They said we linked it into, so unlike previous implementations of virtual memory palace, Clever also takes into consideration group recall and reflection, so it kind of enhances that. It takes advantage of like a fourth dimension to learning as well through time, which is the spaced repetition. So it provides users the ability to scan backwards and forwards in time, and a lot of users commented that was their strongest aspect. What we haven't done in Clever is, and it will be something for future work, we'd actually want to measure the learning effectiveness of combining the Mind Palace, spaced repetition and collaborative learning. So as I say, Mind Palace has been done on its own and in VR. Spaced repetition has been done on its own, and collaborative learning has been done on its own. But this is the first time someone's kind of built a system that's done all three. So the next thing we would want to do is measure, is it actually useful for learning? It looks like it will be, but we need to confirm that through further work. So just to conclude, in the study, we presented Clever, a VR-based learning environment which supports two distinct learning techniques, the Mind Palace or Memory Palace and spaced repetition, and we apply that in the context of learner-led pedagogy. We demonstrated that Clever as a WebXR-based prototype built using A-Frame, aimed at showcasing the feasibility of a low-cost, equitable access implementation of VR-based applications. We conducted two studies which showed that Clever is liked as an application and it's likely to find use if made available to learners. Overall, our results show that a VR-mediated environment combining the Memory Palace and spaced repetition techniques would be a viable, useful and desirable learning tool for the field. And thank you very much. I will take any questions now if you want, or we can wait until we've both presented and we'll go forward. This is where I'm really anxious. As I say, I did it with my master's students, so we'll have to see how much I remember. Hi, someone's got their hand up.
Hi there, thanks so much. That was an interesting talk, and cool that you kind of developed that with master students. Actually, I think that is kind of an interesting added piece to it. The one question you were talking about how it was customizable with these kind of spaced repetitions. Is that right? Like students that went through could decide when and where they wanted those repetitions to occur?
Yeah, so I mean, I'm dredging my memory back up now from when we did this, because this was the end of, no, the beginning, no, sorry, yes, the end of 2020. So yes, so the based on the type of information and the complexity of the information, you can score it in the app, and this is better documented, I think, in the paper. So if you've got a lot of text or the text is complicated, there are some preset algorithms which will suggest timing for you. So you can say the first revision period, and you can put when you need to know it by. So if you're 6 weeks away from your exam, it will suggest, say, 3 or 4 periods. You know, your first day might, your first revision material might be a day away. The next one might be 5 days away. And so according to these algorithms that we found in the previous spaced repetition literature, yeah, it suggests some default timescales for you, but you can adjust them yourself if you want to, but they might not be as effective as the suggested ones because it's based on quite a lot of research. Does that kind of answer your question?
Totally. I was just wondering, did students actually go through and customize things in addition to those kind of recommended time periods? Did you actually see students being like, oh, I want less or more frequent type of things, or did they really stick to that main algorithm?
I think on the whole, they did stick to it, and as I said earlier, because this is more of a user perception and a viability. They didn't have that long in the system to actually do that. So I think in our next version, when we would like, I'm still in contact with some of the master's students. We would like to push it forward, and that will be part of the study where we assess learning and effectiveness. So, for example, one of the things we would compare would be how does learning effectiveness differ between those that left the default algorithms and the ones that changed the timescales for the self? I think that would be really interesting. Yeah, you'd expect the default ones to be more appropriate because that's based on research rather than making their own numbers up. So yeah, there's a hypothesis there that needs to be tested, I think.
Cool. Thank you.
No worries. Any more for any more? Yes, I will do. I'll do that right now. Yeah, that's cool. That kind of so after my degree, I did a teacher training. So I've got a PGCE, and one of my dissertation topics for that was flipped learning and pedagogy as well. So when the master's students they came up with this totally on their own, I was like, I want to be involved with that. That's exactly up my street. Yeah. So the fact they did that in pretty much 8 weeks, you know, including study design, results analysis and write up, I think that's a really solid piece of work for 8 weeks. It's probably better than I did on my PhD anyway. So yeah, and I was there just to, you know, help them go through the appropriate analysis techniques and, you know, how to phrase their questionnaires, you know, stuff that I had experience of that they didn't. So yeah, it's a nice module that teaches them research as well as, you know, practical applications of HCI. So yeah, it was a nice bit of research, I think. Thank you so much for letting us, giving us the opportunity to present it here.
Okay, I think now it's on the center screen, I think. So, okay, so let me start my presentation. My name is Kojiro Yano. I'm from Osaka Institute of Technology, that's in Osaka, Japan. It's 1 a.m. in Japan at the moment, and I have a lecture early in the morning. So right after this session, I have to go to bed and wake up early, then go to my university and do my lecture. So I I will do my best to stay awake and give you my best. Now, my research is about using virtual spaces as a learning media for flipped classroom. The next one. Probably you already know about flipped classroom. That is to allow lectures to be delivered before classroom as pre-class learning material to free up lecture time and prepare students beforehand for more active learning activities in classroom. In Japanese universities, students don't necessarily study very much outside the classroom, and that is a big problem for university lecturers. So we are using flipped classroom approach to give students more time, more opportunities to learn outside the classroom. So improving flipped classroom approach is very important for us. Now, there are several forms of pre-class learning materials. I think most people use videos. Maybe you record videos using Zoom or maybe Google Meet. And some people just provide audios. And some people use Web 2.0 tools as well, like Google Forms. And I do actually use Google Forms to give assignments to students as pre-class learning materials. However, I I just feel that videos are not really good enough for students to learn actively. Of course, they can learn quite a lot from videos, but I just feel that I need more than just providing videos and slides to get students learn more. So I decided to use virtual spaces as a pre-class learning material. It looks like this. The virtual spaces has got a variety of learning materials that actually include videos and a lot of images and 3D models. And there are some interactive elements in it so that they can do some tasks as well. The virtual spaces were created on Mozilla Hubs, and they are mostly accessed by a PC. And some students do have head-mounted displays like Oculus Quest, so they do learn in VR, but most students don't have VR headsets, so they just use PC browsers to browse through virtual spaces. And I usually divide the space into 3 areas by topics. So in each lecture, I usually have 2 or 3 topics, and I just divide the areas by topics, and each area contains a single topic, and that topic is explained by a video and images, 3D models, and text instructions, as you can see from this image. In this image, on the left, you got a video and then text instruction and 3D model and another image instruction. And that's how it usually look like. Now, like I said, each virtual space has got a few try this element, which is interactive exercise in virtual space. I have got 3 types of try this exercises. One is labeling, that is to label something in a 3D structure. For example, in this example, I have got a protein 3D model. Then students are asked to find where a peptide bond is. And if they find the bond, they have to label it using a text label, which is a convenient function in Mozilla Hubs. You can just type in a text and you can make it as a label in 3D space. So that's labeling. Second one is pairing. That is to pair something with something else. So for example, I've got enzyme, the yellow one, and we have got a few substrates, and they have different shape, and only one of them can fit into the active domain of the enzyme. In this case, it's going to be the blue one that can fit into this hole in the enzyme, which is the active site for the reaction. So they can just drag and move to the drag the blue one into the yellow one. That's a pairing. And the last one is discovery. That is to walk around the virtual space and find something in it. In this case, I have got instruction. So there is a radioactive molecule in this virtual space, and as a way of expressing the radioactivity, that radioactivity is detected by a sensor which gives a sound when it detects the radio activity, and the sound gets stronger as the radio activity gets stronger. So they have to walk around and find out where the radio activity is coming from by listening to the sound. Then they just walk around, they discover the place where the radio activity is located. Then they're gonna put a label there to show that this is where the radio activity is coming from. So that's a discovery. So I have got these three activities: labeling, pairing, and discovery. So that's a try this exercise. Now, I use these Wordle spaces in my course. I teach an introductory life science course in my university, and each course has got 14 lessons on Google Meet because it's just COVID. So I did all my lectures online, and with 2 exams at 7th and 14th of the lessons. And some of the lessons didn't use Wordle spaces, so 8 of them, so 8 of 14 lessons used Wordle spaces for pre-course learning material. Usually pre-course learning included a Wordle space, a Google Slides, and assignments on Google Forms. And in-class learning included lecture and the try this exercise, the one I explained, and a revision exercise, which is a multiple choice questions. Now, so I did a survey and the simple questionnaires on Google Forms. And first I asked how often they used the Wordle spaces. So like I said, I provided 8 spaces. And the blue one in this bar, they are the one who used all 8 spaces. And this one is almost all, so 6 or 7 spaces. Then 3 to 5, and 1 to 1 or 2, and none. And I labeled those who used 6 or more spaces as high usage group. And pre-course learning, 69% of the students were high usage category, so they used 6 or more Wordle spaces. And when they're preparing for exam, they also used Wordle spaces as well, which is nice, but the usage was a bit lower. So 46% of them were in high usage category. Well, so of course, the Wordle spaces were primarily designed for pre-course learning, but around half of students seems to think that they can also use it for exam preparation. And then I did another question. So I'm sorry. This is just to compare the 2 groups. So 2 questions. So the questions for pre-course learning and questions for exam preparation. So among the 90 students I surveyed, 37 students were in high usage category in both situations. I mean, in pre-course learning and exam preparation. However, 25% students changed from high usage to low usage when they did the exam preparation. And 24 students were in low usage in both cases, but 4 of the students moved from low usage to high usage when they did exam preparation, which seems to show that some students found the usage of Wordle spaces when they attending lectures, then they decided to use it more when they're preparing for exam. Now, next one. Next one is the perceived overall usefulness of Wordle spaces. And for this question, I asked it in 3 different situations. First one is for pre-course assignments. Second one is for understanding lectures. The third one is for exams. And I asked the question in 5 Likert scale. So from very useful to not at all useful. Then the average rating was the highest for understanding lectures, which is 4.43, which I think is quite high, and followed by pre-class assignments and for exams. So this seems to show that, I like I said, I prepared Wordle spaces for pre-class assignments, but actually the students thought that was more useful for understanding lectures, which is not not a bad thing, I think, but maybe I didn't design the virtual spaces really suitable for the pre-class assignments. Maybe it uh, the things they can learn from virtual spaces and the one required for previous assignments were not closely matched. That might be the reason why they thought that it was less useful compared to understanding lectures. Now, the next one. And I asked the same question for try these exercises. So perceived usefulness or try these exercises. And I was expecting that try this exercise is going to be very, very useful. I mean, because it's interactive and actually quite fun. And when I'm watching the students doing try this exercise, they looked quite excited. So I was expecting that the perceived usefulness of try this exercise is going to be a lot higher than overall usefulness. But I was wrong. For understanding lectures, it's not that different, almost exactly the same, 4.43 to 4.44, so almost exactly the same. But for previous assignments and for exams, actually the no, I mean, sorry, for previous assignments, the rating has dropped. And for exams, rating was a little bit higher, but not that different. And for understand lectures, it's almost exactly the same. So actually, I didn't get any significant improvement for try this exercise. So students didn't necessarily think that this kind of interacting exercise is significantly more useful than overall usefulness. That was a bit of a surprise for me. I also asked 3 comments from students. I first asked on what is the positives and negatives of virtual spaces, and I picked common nouns and verbs from the answers. Then the positives one, like that included three-dimensional and three-dimensional and 3D. So they obviously liked the 3D nature of the virtual spaces and understanding. So that means they thought that virtual spaces helps them to understand lectures. Then verbs, that is like can do, move things, and look. So mostly that is about doing things, obviously. Particularly, I think can do is quite interesting because students don't say I can do this, I can do that. When I ask their perception on, say, videos or slides, but in virtual spaces, because they can do interactive things, they feel that, oh, I can do this, I can do that kind of stuff. For negatives, it's about manipulations, movements, and assignments, and required time, these kind of stuff. And I think some of the students found that moving and manipulating things in virtual spaces is not user-friendly. I didn't think modular habits is particularly difficult to use, but and most students play 3D games, so I thought students wouldn't have problem with moving or manipulations, but some students did find those things difficult. And that's why it takes time for them to finish the assignment, and that is the answer of that requirement time stuff, I think. Now, and I also asked students to say something about how I can improve the virtual spaces, and they are also mainly about manipulations and navigations, like want better instructions for manipulations, and it was difficult to find where the videos were. It was difficult to know the order in which to browse, that sort of stuff. So it's pretty similar. So, so that's my presentation. So I did I used virtual spaces for previous learning in flipped classroom, and I think the overall perception worked quite good. But I still have lots lot of stuff to improve, particularly for manipulations and navigations. And that's the end of my presentation. Thank you very much. Okay. I th I think instruction is quite important. The problem was because I was giving lectures on Google Meet, so I'm not teaching students in person. So if student had problem in manipulation or navigation, I really can't help much. But in classroom, I think I can just go to them and show them how to do it in person. So I think things can be improved a lot. So if I do the same thing now, because now we are doing the face-to-face teaching in my university, so I can teach them in person. So maybe these problems would decrease if I do the same survey again. Yeah.
Hi, thank you. Yeah, great. First of all, well done. That was a great presentation. I love the way you've moved flip learning on from the standard let's play a video that winds me up no end. So yeah, to see you move into virtual spaces, I think that really leverages what flip learning is all about.
Yeah.
So yeah, mine kind of goes back to your which you had to slide 12, which was your manipulations and movements. So just to confirm, you did this in Mozilla Hubs, yeah?
Yeah.
Yeah, so you're restricted by their default UI interaction techniques, yeah.
Mm.
So do you think it's worth doing what you're doing in more of a bespoke environment, somewhere like if you develop, say, in Unity, where you've got more control over uh, the interaction techniques, and you make that easier? Do you think it's worth exploring that way?
Well, I did think about that, and I'm actually do have a grant to develop app using Unity, but the problem is when you develop app for browsers using Unity's WebGL capability, it tend to be kind of heavier than Mozilla Hubs. Mozilla Hubs is good because it's quite lightweight, so even the quite cheap computer is good enough for running Mozilla Hubs. And my students don't necessarily have expensive computers. And I do all lectures using their uh, not PCs, and we do so-called BYOD. So students bring their laptops to the classroom, then use Mozilla Hubs. So, and some of the students have really have the students' PC can be quite low spec. And I'm just worried that maybe the Unity-based apps don't run very well on these computers.
Yeah, I think that makes entire sense. Yeah, I think we've got a bit of time for the convergence between the lower spec catching up with kind of where we want it to be. But
Mm.
yeah, interesting study. Thank you.
Thank you very much.
Yeah, I have a question, kind of two. One is how, like, just a rough estimate, how long did it take you to like design these pre-learning spaces? And then kind of connected to that, how did you just dress designing the spaces? Because I know you mentioned that you might improve the design on it, but like, how did you think about putting this model there or that model there and so forth? It's very interesting.
Well, actually, Mozilla Hubs do have quite a few sample scenes, so you can just use them to to use them as background 3D space. But I have to spend a lot of time to prepare 3D models for example, molecules or cells, that sort of stuff. And it took me about 4 or 5 weeks to prepare 8 virtual spaces. So that is quite significant investment for me. But once you create that, then you can use it every year. So I think that investment is worthwhile.
Thank you.
Thank you very much.
Hello.
I just had a quick question. I thought this is really cool idea. As soon as your presentation started, I actually hopped into Mozilla Hubs for the first time. And then as the more you were talking about it, I was like, oh, interesting. I was finding even moving around within it is kind of awkward within there. And I thought Robert's idea of doing the Unity thing was interesting, but then as you were saying, that's a little bit heavier. So yeah, this has been super informative. I was just wondering in terms of the content, like was this were these different rooms for each of the classes, or was it one large space that students were moving around? Let's say, okay, you move into this room and then you can walk to the other room for the next class. Or like how was it actually laid out spatially within the rooms available on hubs?
Well, I prepare a space for each lecture. So, for example, the lecture for protein and a lecture for a DNA, they're going to be totally separate because it's a web-based, web browser-based. So the memory size is not great. So I have to keep the space as small as possible. And also, I don't let students to share rooms together. So I assign room to each student. So in each student is going to have their own room to work on the assignments so that, it's not going to be too heavy because as you know, on WebXR, if you have, say, 20 or 30 people together, then it's going to be super heavy. And I teach 100 students at the same time. So I don't want the students in the same room. So each student is going to have their private room where they're going to walk around the virtual space.
Okay, and is it very easy to set up those kind of private rooms for each individual student? Like you send them some sort of personalized link or something, or how does that work?
Yeah, you can have you can prepare a link to students. Then that link allows students to generate their own room. So it's very simple.
Okay, that's great. Thank you so much. Really, really cool stuff.
Thank you very much.
Hi, I have a question.
Yeah.
Great. Hi. First of all, thank you so much for your video in which you had the avatar. So I watched your YouTube video, and it's really nice that you had an avatar to go with it.
Thank you.
Then also, I really appreciate you staying up so late.
Thank you very much.
Sure. So my comment is about the virtual things that people were manipulating, and the way you said that they didn't feel like physically manipulating things was so effective. So I have a comment and then I have a question. My comment is, I wonder if when they were doing the physical manipulations, might have actually been a really good learning experience, but then they didn't use it for studying for the test. Maybe it's possible that when they were studying for the test, they could remember the virtual manipulation, and so they didn't have to like redo it. So I wonder if it's something about the type of content and the fact that maybe it's easy to remember, and so they don't have to go back to it. So your low results might actually be good results.
Yeah, actually, I'm thinking exactly the same thing. So even though those manipulation stuffs are helpful, but they are not necessarily related to the questions or the exam questions they have to work on. Because in exams, I have a lot of multiple choice questions, and also they have to write a small essays, and none of them are directly related to spatial manipulations. So that's why they didn't feel that they are using the experience in virtual spaces for exams or even pre-class assignments, because in pre-class learning assignments they have to write small sentences as well. So that's not necessarily spatial manipulation stuffs. But of course, they to work on exams, they have to understand the subject. And like I said, they said they thought the virtual spaces were useful for understanding lectures. So it should indirectly help students to prepare for exam and all that. But because the virtual spaces and exam questions are not scaffolded properly, so I think I should show students how virtual spaces can be useful to, work on exams, other stuff. And I have to, maybe I should demonstrate the link between the two, then they can feel more about the usefulness of virtual spaces. But anyway, I do think actually they helped, those virtual spaces helped students to even work on exams, but I don't know how to prove that. Probably what I should do is to have two separate groups, randomized controlled trials. One is without virtual spaces and one is virtual space with virtual space, and let them take the exams. I think that's the only way I can show the effect. But otherwise, I can't really show that I can really prove that virtual spaces were useful to not just understand lectures, but working exams as well.
Yeah, I think the issue is like when you are doing this kind of research and you ask people to say their opinion, they might not be able to make kind of the mental connection. Like maybe that experience is influencing them, but they are not able to think about it. And so, yes, I think doing some controlled study of having two groups of students, one of them you allow them to manipulate things and don't allow them to manipulate the results. I think that if you just measure their learning gain, give you a good result. I'm also curious about there's an interesting discussion here about the connection between the assessment, so the way you ask questions to students on the test, and the activities you are doing in the virtual world, and how connected they are, and how people can think. There's a question here about should you adapt the test so that it matches the knowledge that they learn in the virtual world? Maybe they're learning things, they are not transferred to the test. Or maybe the activities you do in the virtual world can be more complicated or more, I'm not sure, it can be more close to what's happening on the. There's an interesting design space here.
Yeah, the problem with Mozilla Hubs is that it doesn't really allow me to create anything complicated. It only allows very simple interactions. And if I want to do anything complicated, then I have to use Unity. But so I'm just thinking about whether I should modify the exams to fit the virtual space learning, or I should change the virtual space learning to fit with the exams. So I have two choices. At the moment, I'm trying to modify the virtual spaces within the limit of Mozilla Hubs. And I'm actually doing this, trying to do this year. Then if it doesn't work out very well, then maybe next year I'm going to work on Unity-based virtual spaces.
I do think that, and sorry, I don't want to monopolize the conversation here, but I do remember, I haven't worked personally with Mozilla Hubs, but I do remember they have some sort of scripting or programming ability. I think if you want to do more complicated things.
Yeah, there is you can have your personal you can host personally the Mozilla Hubs. That's called Mozilla Hubs Cloud. Then you can do some modifications, but it's actually quite complicated. I'm trying this at the moment, but it's actually quite complicated. Actually, doing that in Unity is easier because Unity is more helpful to build interactive contents. So, and I did actually use Unity quite a lot. You saw my avatar in my video presentation, and actually that application was based on Unity. I'm built it myself. So actually, I do know quite a lot about Unity, so I can actually use Unity better for more complicated interaction materials, I think. Yeah.
Awesome. Thanks, everyone.
Thank you very much.